Welcome to TINACloud, the cloud-based multi-language version of the popular circuit simulation software Tina Design Suite, now running in your browser without installation anywhere in the world. TINACloud runs on most operating systems and computers, including PCs, Macs, thin clients, tablets, even on many smartphones, smart TVs, and e-book readers. TINACloud allows you to analyze and design analog, digital, microcontroller, switched mode power supply, radio frequency, communication, and optoelectronic circuits. It also allows you to use manufacturers' SPICE models, hardware description languages, and test microcontroller applications in mixed circuit environment. In this tutorial video, we will show you how to create and analyze a fourth-order active filter circuit using the SPICE model of the OPA364 operational amplifier. Go to the Tools menu and select Schematic Editor to create your filter circuit. Fourth-order low-pass filters are normally composed of two cascaded second-order blocks. Create the first block like the one on this sample schematic. Click the voltage generator icon on the component toolbar. The schematic symbol of the generator will appear attached to the cursor. Position the symbol using the mouse, then left-click to place it. Next, place the two horizontal resistors in the same way. Now, place the two capacitors. The second capacitor should be rotated by 90 degrees. You can rotate parts even before you place them by clicking the Rotate Left or Rotate Right buttons. You can also rotate components after they are placed. So far, the components were inserted using their default values. Double-click a component, and the property dialog will appear. Enter the required component value and press OK. Repeat this procedure for all components where needed. Now add the operational amplifier to the circuit. Click the SPICE Macros tab at the Component toolbar. The toolbar of the SPICE macro components will appear. Click the Operational Amplifiers tab. The list of the available operational amplifiers from different manufacturers will appear. Select Texas Instruments. You can now select the op-amp from the list, or enter the part number into the top left search field of the dialog. Depending on what you enter, several ICs may appear. Enter OPA36, then click on OPA364 and press OK. The selected IC will appear attached to the cursor, and you can move it anywhere by moving the mouse. Move it to the right location so you can easily connect it with R2 and press the left mouse button. You still need to add a few more components. Go back to the basic component toolbar and add a power supply and two grounds to the circuit. Now you can wire up the circuit. Note that TINACloud has an advanced wiring tool that automatically inserts the components into the wire. Position a few component labels. You can also move components along the wires or modify the wires themselves using the rubber line capability of the tool. Now, the first block is ready. Create the second block using multiple selection, copy, and paste. Press the multiple selection button. Using the mouse, now you can select and deselect components by clicking or by window selection. Select the required part of the circuit to copy into the second block of the filter. Release the multiple selection button, then click the copy button or use the Ctrl-C hotkey to copy the selected block of the circuit into the clipboard. Click the paste button or use Ctrl-V and the copied circuit will be attached to the cursor. Move it across the screen and place it with a left click. Connect the new block with the first block by wires. Finally, add two outputs to the circuit using the voltage pin components from the meters component toolbar. Now, your circuit is ready for testing. Save it under the name Filter Circuit. It will be saved into the My Circuits folder on the server under your account. The circuit will appear in the main window of the program. Click the Analysis menu, select AC Analysis, and then AC Transfer Characteristic. The AC Transfer Characteristic dialog appears. Set the frequency range and then press Run. Several diagrams will be generated, including amplitude, phase, Nyquist, group delay, and Bode diagrams. You can run two cursors on the diagrams and read the values and the difference. You can also add diagrams to the schematics and store them together. This is a great way to document your design. To do that, invoke the schematic editor using the Tools menu or simply by double-clicking at an empty spot on the workspace. Select Insert Diagram from the Insert menu, denoted by a plus symbol, and then select AC Bode 1 from the list. You can also resize the diagram if you want. Press the OK button. The diagram will appear attached to your cursor. Position it and then add it to the circuit diagram by pressing the left button of the mouse. Use the Zoom All command so that all objects will be visible. Add labels to the curves using the Text tool and the title of the circuit. Pan the circuit by holding down the left mouse button and moving the mouse down. Now, add the title using a larger font. Finally, save the diagram by pressing the Save button. The circuit with the embedded diagram will appear in the main window. The circuit is already saved in your My Circuits folder, but you can also download it to your own computer or upload to Dropbox. You can create and analyze your own circuits in a similar way. Enjoy using TINACloud. www.tinacloud.com